All right. Am I live? Let's do this. Hey guys, it's Anshul here. I am the founder and CEO of Camp K12. I joined you for last episode, which was episode 38. I had a great time with Matthew, a young 9th grade coder who joined us from Canada, from Toronto. And I had so much fun, in fact, that I had to come back for one more episode and maybe a couple more after that as we make this global world tour all across the North American region to Middle East and Southeast Asia and all across the world. Today, we have a very special episode, and I want to talk about why this is so special. For the last 11 years that I've been teaching coding and that Camp K12 has been teaching coding to kids in many different countries, there's been one topic that keeps coming up again and again and again that students want to learn, and that is 3D game development. And so in a lot of our curriculum at Camp K12, we do a lot of 3D game development. Now, there are many platforms out for 3D game dev. A lot of our students use a platform called HatchXR, which is a Camp K12 developed 3D AR VR creation tool. Some of you know that there are games out there like Fortnite that are built on different platforms, like the Unreal Game Engine. There's also Unity. There are all these other tools that are used to make some of the more advanced games that you guys play on your phones, on your laptops, and professional level games. Today, based on popular request and popular demand, we have a young coder who is in 6th grade and is a Unity game development pro. He codes in his free time. He makes games. He can make 3D games in like an hour each. And he's gonna today, in less than 60 minutes, show us how to make an awesome 3D Asteroid Shooter Game. So with that intro, let me ask our guest today, Rohit, to turn on his video and say hello to our live audience on YouTube. Hey, Rohit.
Hi.
What's up, man? How are you?
Nothing. I just woke up like an hour ago.
Woke up an hour ago. Guys, he is in California. So Rohit, why don't you tell us where you are? Because that'll help us get a sense of what time it is and why you're just waking up. We have people watching all across.
I'm in Pacific time, so PST.
Pacific time.
And
PST.
Right. And it's 7:30 right now, and I'm in Fremont, California. Right. So like, I think
yes,
West
that
Coast.
Is the West Coast. You're right, my friend. It's early, but it is the West Coast. So you woke up at 6 o'clock approximately. Then you woke up at 6.
Yes.
Bro, do you frequently wake up at 6 on weekends?
Yes, pretty much. Just because I want to code. It's like the only thing to do.
You wake up at 6 o'clock to code on a Sunday.
Yeah. That
is remarkable, guys. So this is why Rohit is our super coder today. He has been coding for quite some time. And, we have been in some of the same classes of Camp K12 together. And I saw his skill and I was just very impressed. So I invited him to come be this Camp K12 super kid for today's TV episode number 39 and share his hobby of waking up at 6 a.m. and coding with all of you on live TV. And so that's why Rohit is here. Rohit, thank you so much for joining us all the way from Fremont, California. And we are very excited to learn Unity from you. I think you're going to do a great job of making it really accessible and fun for other kids your age, because believe it or not, from every country in the world that we teach in, the question keeps coming up, hey, can we move to making really advanced games on Unity or Unreal Engine or some of these other game systems? So we're very excited to see you. Now, before we get started on the coding, I want you to tell me a little bit about your life right now. So we're sitting in June, and if I'm not mistaken, your school year must be wrapping up around now. Give us a sense of what's going on right now. What's happening on the weekdays in life?
Well, I just graduated on Wednesday, so June 9th.
Wow, you are fresh from graduation. So you are grade 6 and you just graduated going into grade 7, I'm guessing.
Yeah.
Yeah. And that's middle school now. So you're going into middle school. Congratulations.
Yeah, technically I was supposed to graduate in 5th grade because in most places 6th is middle, but for some reason in my district it isn't. That's weird.
Education systems across the globe are just weird. And even within particular countries and particular cities, they can have different systems. But what matters is that you are someone who likes to teach yourself new skills and really important skills outside the school system. So it doesn't matter if someone calls you a middle schooler or an elementary schooler or a high schooler, because you can make 3D games doesn't matter what age you are and doesn't matter what grade you're in. And that's what's so awesome about what you do. And that's why you're here with all of us. So Rohit, how did you get into Unity?
So I just started out doing Python and Scratch, and then after that I got an interest for like other things. I wanted to make 3D games, that sort of stuff.
How many times in a week do you code 3D games?
Mostly.
Every day. You code 3D games every day. How many hours a day do you code 3D games?
Well, according to my screen time, about 4
hours. Are you measuring
hours.
this on an app on your computer, on your phone? How do you measure that?
Yes. Yeah. It just says Unity 4 hours screen time.
That's amazing. Which app is that you're using to measure?
It's just literally the screen time app on Mac.
Okay. Awesome. So guys, Rohit from Fremont, California, wakes up at 6 a.m. to code on a Sunday, spends about 4 hours a day during the week coding Unity 3D games. So we are very lucky, Rohit, to be able to learn from you with all the experience that you have. Before we start coding, why don't you show us some of your build? Some of what you've built. So you definitely have talked to us about what you do. I think we would love to see what you actually create during that time. So over to you to share your screen and walk us through some of the things you built.
Okay, so the first thing I've made is a fruit ninja, similar to game. And you get to slice fruits, you get points.
Nice.
It's actually a pretty nice game.
This is a Unity 2D game, right?
Yeah, it's pretty much 2D.
Yeah.
But all the models are 3D, but it's mostly 2D.
Awesome. All right, you got a score 230. I can see that. Nice.
All right. So the next one is wait. Oh God.
That's okay. You can show us the games in whatever order you want. This one looks like a 3D game. Yeah.
Yeah, this is a 3D game. It's it's like a parkour game where you dodge all the obstacles.
Can you jump? Can you jump?
Well, you can't really jump, but there are ramps. So that's...
Oh, nice. And with real physics. So like when you went off that ramp, it had some lift and it just kept going. The acceleration kept taking it up.
Yep. That's due to Unity's physics engine. It's actually a pretty good physics engine.
Awesome. So, and I can see you built multiple levels in here because it changed
2 levels.
Okay, awesome. Now we're looking at a 2D game. Which one is this?
This is like a lunar lander. You try to land your rocket on the green platform without crashing.
I've played this one. How do you detect the collisions between the rocket and all of these game elements?
I'm using Unity's collision system, and this is my Asteroids game.
This one looks super pro. This is your game. You made this?
Yes.
That's amazing. How much time did it take you to make this?
Around like an hour.
That is amazing, guys. I think we should give Rohit a round of applause already. We're just at the beginning of the session, but Rohit, congratulations on being a super coder and on
Thank you.
Congrats to you. So,
thank you.
Which of these are you going to teach us today?
I'm going to be actually teaching this one.
Oh, wow. Lucky us. You picked my personal favorite as well. I think this one looks the most complex. So you're going to show us how to do this in 1 hour.
Yeah.
In 1 hour.
Yep.
I wish I could see the faces of our audience members right now. I wish they were on the Zoom with us, but we'll have to go look at them later. But that is remarkable if you can teach us how to do this in 1 hour. So, well, let's dive into it, right? I think you are our guest today, and I would like you to run the next part of the session. So tell us how you would like to teach us. And by the way, let me just mention that Unity is a game engine which you have to install. So unlike the Camp K12 3D platform Hatch, which you can run on your web browser without any installation, Unity is a very heavy file. So you'll have to install it. So this TV I encourage all our learners who have Unity installed on their system already to just watch what Rohit does and just listen to him and understand what he has to say, because it's going to take you too long to install Unity. If you have Unity installed, you're welcome to open it up and try to follow along. But I think you guys are going to have a great time just watching what Rohit shows you. And I'm going to be watching you, Rohit. And later on, you guys can download Unity. We can share your game file in the description of the YouTube video. I
have a zip file of the template.
Awesome. We'll share that at the end. So guys, if you're not able to follow along with the code, don't worry. We will share the entire Unity project file in the YouTube video description itself as a link. All right, Rohit, over to you.
All right.
I would love you to, yeah, go ahead and share the screen. Awesome. So
this is Unity. Okay. Yeah. So first, two important things. This is what's called a hierarchy, as you would see here.
Is there a way you can zoom in a bit, Rohit? I can already tell that on your screen it might look really high resolution, but when it gets streamed, if there's a way to zoom in, it would be great. Otherwise, don't worry about it. We can always later on, at least for the code, we can zoom into the code.
Okay, yeah, I can't really zoom in on Unity. I can zoom in on the code, but yeah.
Yeah, no problem.
So this is the hierarchy where everything in the game is displayed. Like the camera, the spaceship, a light. Yes, you need lights for everything to show up. Right. Unless if you don't have lights, everything's just dark. That's just how it is. So a directional light is like a sun. That's why they have like a sun, symbol.
Yeah.
And this is just an object I have, which spawns asteroids. And
so an object is something you can just create, right? It's not a built-in thing in the Unity, right? You made this. You made the spawner.
Yeah, spawner, this is an empty game object, which you can right-click and create. But then I have a script on it, which I made, creates asteroids.
So what I'm learning from listening to you is there are some built-in shapes or objects like lights and shapes or models like, is spaceship a game object or spaceship a 3D model?
It's a 3D model, but there are some pre-built ones. You can create 3D object. You can create cubes, spheres, capsules, cylinders.
All right. So if you want to make your asteroids be spheres, you could do that, right? And you've used something else to create the asteroid.
Yeah, I got this model from Google Poly.
Okay. All right. So can you tell us what are all the game objects in your game?
So all the game objects. So this is an event system. This just detects events like clicking, that sort of stuff. This is a canvas, and if I zoom out like a lot, if I zoom out here, if you can see, the canvas is like a big, gigantic square. And it basically represents your screen. So whatever, this is like your screen. It represents your screen.
That's not in 3D space, right? That'll be a heads-up display above everything else that's rendered behind.
Yeah.
Okay.
So like the text, wherever you put on this box is where it's going to show up in the game. So if I move this text like here, it's going to show up right there in the game.
Awesome. Makes sense. And for those of you who are watching this, those of you who are part of the Camp K12 community and are taking courses with Camp K12, you will recognize that a lot of these concepts are similar to what you'll find in Hatch XR. The concept of having directional lights, ambient lights, and other types of lights as built-in primitive objects in the platform. It's the same. I guess a few things are different, like the way you have to create a game object and then attach a script to it. That's a little different because in Hatch, it lets you just have a code editor where you have a global script. And I think that's one difference. But I'm seeing a lot of similarities, and I think so will our audience across Unity and Hatch. So for some people, it might be easier to understand. Go ahead, keep going.
Yeah. And then after the hierarchy, this is like another main part. This is the assets. This is where all your scripts, your scenes, which are like levels basically, your scenes, your scripts, all your models, everything's going here. Okay. It's like your main download page or something.
So wait, for those who can't see it because it's too small, let me just read it out loud. I'm seeing an asteroid 3D model here in the assets section. I'm seeing a bullet 3D model here, and the bullet is a green. Is it a 3D model or is it a blob? It's a sphere. It's a sphere.
Yeah, it's a sphere. It's just a green sphere.
You added a sphere, you colored it green. Okay.
Yep.
All right. And where is the spaceship?
Spaceship is, I believe, in this one. Nope.
Okay. All right. Yeah, so things can be inside folders as well.
Yes, you can create folders. Okay. That's actually a good practice to create folders because it's more organized. You can find everything, especially if you're making a bigger game.
Makes sense.
This is a material that you can create. Materials just allow you basically to color things. So if you were to just create like a sphere here and zoom in on the sphere, because we can't really see it. Oh God. There it is. So it's white. That's just the default material, as you can see here, default material. And if you click on this arrow, you can see all its components, but you can't actually edit anything. That's just because it's the default material. So if you want to actually edit it, you have to right click here, go to create, and there's like all this big list of stuff, material. And you can just name this, I don't know, anything. Okay. And here you can edit this. So I can make it like, I don't know, purple or something.
Yeah.
And if I just drag it in, there you go.
Most that looks cool. It has the lights and shadows are just working like magic.
Yep.
In the scene. Yeah, that's cool. And I think most game systems, whether it be Unreal Game Engine, whether it be Unity or Hatchjigsaw or anything else you use, some of these concepts are the same across all of them, right? You have the concept of layers in Hatch, and then you can customize the material on that object on the right side. And these are, largely speaking, entity component systems is what we call them in the technical language of 3D engines and game systems. One thing I'm curious about, the games you're making that you showed us in those videos, they have physics. So I saw your cube slider game. When you go off the ramp, it looks super realistic. It just keeps going and then it falls. How do physics work in Unity? Is that something you have to code, or is that something that's just done for you? How does it work?
So Unity is very nice, and they have given us like an amazing system. So they have like their own physics engine. It's just amazing. It's very, very nice. And all you have to do to use it is add a rigid body. And a rigid body is like, you're just telling the Unity engine that this game object has to use physics. It's like, it just tells the game engine that you have to use physics. And you can
the rigid body is this component you have to check the box here and like put it on something, or is it by default enabled?
So it's not default. It's not on the game object by default, but they have an add component, and you can search for rigid body. There it is. Or is it a 2D version or a normal version?
Okay, all right. So today, are we making a 3D game or a 2D game?
We are making a 3D game, but we are making a 2D game, but like you can turn it into a 3D game. Okay.
So for everyone watching, Rohit is going to help us build that Asteroid Shooter game. He's going to start with a 2D game so that you can focus on the game development concepts. Then he's going to show us how to turn it into a 3D game. But you're still using 3D models even in your 2D camera view, right? Yep. It's like a bird's eye view is what you're building.
Yeah, there it is. Okay. It's like a bird's eye view.
This is our bird's eye view because you put the camera at the top. Okay.
Yeah, awesome. So if you play now, it does absolutely nothing. Well, there's asteroids coming at you, you can't do anything. They eventually just push you.
Is this the play mode?
Yes, this is play mode.
I see the asteroids. Awesome. And they are.
You can't move. You can't do anything. It's just
So this is our default game state that we're starting with. You cannot move. You cannot shoot. And are there any collisions between asteroids and the ship?
There are collisions, but the collisions don't do anything yet.
Okay. We haven't done any code. All right.
Yeah, they just push the spaceship around.
So in the time that we have, and again, we have, I'd say maybe 45 minutes, let's say 30 minutes. Okay, let's do this in 30 minutes. Let's say 30 minutes. In those 30 minutes, what would you like to teach us?
I would like to teach how to make the spaceship move and how to shoot.
So number one, make the spaceship move. In what directions are we going to move the spaceship?
We're going to be moving forward, backward, left, and we're going to rotate left and right. So you can, turn.
Wow. So that sounds advanced. It's not just like straight up, straight back, straight left, straight right. It's turning.
Yes.
It's turning, which requires physics. Yeah. So are you going to teach us some physics?
Well, not college level physics, but yes, some physics.
Not college level physics. That's all right. I think that game development physics is quite advanced, and honestly, it's like high school level physics. And you just graduated into middle school, so you'll be teaching us high school level physics, and that is amazing. So I'm looking forward to learning that. Number one is how to move the spaceship, and by turning it, not by moving it, just teleporting it. And the second thing you said is shooting.
Yeah.
Wow. And I saw you playing the game earlier. And so that sounds very impressive because those bullets looked even more amazing than the old school arcade games I used to play because the bullets were turning. They were like curving as I rotated my ship.
Yep. They shoot forward wherever you face your ship.
Yeah. Okay, so if you turn the ship and you fire, it goes that way. And then if you turn that's awesome. So the bullets are intelligent in the sense that they are being fired from where the guns of the spaceship are, right?
Yes.
And they're going in the direction in which the spaceship is looking.
Yes.
Yeah? Awesome. Can you show us that video one more time? Do you have it up of the asteroid shooter?
Yeah, I can open it real quick.
Yeah, just real quick because there it is. So guys, we're going to learn how to move by turning like you're seeing it here. Rohit, just walk us through it again. What are we going to learn while this?
So we're going to be learning to move. We're going to go forward, backward, and then rotation, left and right, and then we're also going to be able to shoot by facing the way we want to shoot. And
it seems like detect collisions between the bullets and the asteroid.
So if you hit an asteroid, you're going to get some score added to your total up here, and you're also going to destroy the asteroid.
This is a phenomenal game, and the fact that you made it in 60 minutes, I still can't believe it. But let's go ahead. Let's dive in, Rohit.
Okay. So the first thing we need to do is add a script onto this game object so that we can actually make it move. You can click Add Component and search up Movement, which is a script I already made. So before we start coding, actually, I really think we should just put values that I found were really good because,
Okay.
So the first rotate speed is going to be how fast your spaceship rotates left and right. Okay. I found 150 is pretty good amount. I mean, you can play around with it, find what you find is good.
Before you start filling this in, let me just understand. You added a script called Movement.
Yes.
Right? And that's something you created.
Yeah.
It's not something built in.
No.
And why am I seeing these variables here? Rotate speed, speed, max speed, shoot speed. Did you define those variables?
Yes, I defined those variables.
Can you show us in the script where you define those variables? Because that'll help us understand. Because otherwise people might think that, hey, Unity provides you these things, but no, you wrote this.
So basically, when you're in the script,
let's start with some basics. Right? What programming language are we using today?
This is a programming language called C#. It's it's what Unity uses. Well, Unity used to use JavaScript, but then they just abandoned it.
Oh wow! All right. And so, can you show us the top of this? Actually, while you're on the code, I can see you have 3 tabs open. You have movement.cs, spawner.cs.
Yes. And then destroy asteroids.
So you've already written the destroy asteroids and spawner code.
Yep.
All right. And we are now working on the movement code.
Yes.
All right.
I wrote some of the code for the movement, but we don't actually have the movement code.
Got it. So line 36. Can you zoom into the code, Rohit?
Yes. There we go.
Right, there you go. That's so much better. So there it is. I can see line 36 says main game code goes here. But I got really intrigued by the fact that you had these variable definitions up there. Can you scroll up?
Okay, so basically how in Unity, how it works is if you use a private variable, first of all, a private variable is something that only this script can access. So if you put up like this rigid body, it doesn't have anything in front of it. So that means it's private. So that means like if I wanted to access this variable from like, for example, spawner, I literally just cannot do that. I can't just say like movement dot, rigid body.
Yep.
Because it's not public.
Okay.
And what a public float or like publics would do, if you put a public, you can access it from any script. And it's also accessible in the editor. So I can edit it in the editor without coming back to the script.
That's what I was trying to understand. So there's a connection between the public variables you define and declare in your C# scripts. So the order in which you did this is you first created that script, you defined some variables, then you attached that script to your game object. Yeah. And then it automatically, in coding, we call it parsing. It parses that script. And it interprets it and it says, look, there are all these public variables. Let me expose that in the UI of Unity for the game developer to enter in the editor itself, right?
Yeah.
And
it just makes it easier.
Okay, go for it. Yeah.
Okay, I'm just going to enter all the values now so we don't have to do it later.
It makes it so that you don't have to go back and forth between code and design.
Yes.
Right? You can configure the game mechanics here.
And a really cool thing about this is where it says none game object, you can just literally, for example, for the bullet, you can just drag in bullet like this.
Okay.
That's it. It's assigned.
Awesome.
And so if you click on this little arrow, that's going to show you all the children of the object, which is objects that are attached to that object.
Yep.
And you can drag in gun 1 and gun 2 for gun 1 and gun 2 pause. Just
all
like
right.
that. And for score, obviously we want the score to start at 0 because, yeah, that's just, we need the score to start at 0 because, yeah. And then we're going to drag in this text, which is going to be this text right here, score.
Awesome.
Yeah, there we go. Now everything's assigned. And now we can just go into the code.
All right, let's go for it.
So mainly all the coding we do today is going to be in the update function. It's a function that...
Before you dive into the update function, let's just show our audience what all functions are in this script. Because I can see line 29 has a function called start. Line 34 has a function called update. Yeah, go ahead and highlight that as we're talking about it. Start, update.
Yeah, this one.
Yeah, that's start. And then there's update. That's a function. Then there's destroy bullet. Yeah.
That's a coroutine.
Oh, that's a coroutine. Okay. Which is a technical term that Unity uses. We won't dive into that. And then there's on collision enter and on trigger enter. Can you define what those two functions are? I can see you've written some code there.
Okay, so on collision enter is, I think it's easier if I explain in the editor. So on collision enter is on, for example, okay, wait. If you see here, yes, here, I have a mesh collide on this. And on every collider you add on an object, it says is trigger. And if you checkmark it, that means it won't actually collide with things, but it can detect collision. Like it's going to go through it, but it can still detect collision.
Got it.
So if you don't have it enabled, it's like a rock wall. It actually collides with each other.
Okay.
Yeah. So basically, that's basically what I'm doing here. This is game over. I used to have a wall so that you wouldn't be able to go past the boundaries, but then I just removed it for now because that became so that you kept dying whenever you went out. So, and collision enter is whenever you don't have trigger enter enabled in the editor.
And so what objects are we going to be colliding with in this game?
We're probably going to be colliding with maybe some bullets, some asteroids. Yeah.
Okay. Some asteroids is probably the main one, right? In fact, the spaceship is not going to collide with its own bullets, right?
Yeah, maybe. I don't know.
It's up to us. We can do whatever we want, right?
Yeah.
So for now, I think the way you've written it is anything other than a collision with the gun itself should trigger the scene to change to a game over scene. Is that right?
Yes.
Load scene 1 changes it to
because
game
there's
over.
only one other object in the entire scene, which is asteroid.
Yes. So guys, line 48 through line 53, the on collision enter function says that, so this is code that's already written. He wrote it before this session to make it easier for us. It says that if our spaceship, which is a ship that's the game object that has this whole script attached to it. If the spaceship collides with anything other than the gun, in this case, that means asteroids, scene manager...
No, that's... Gun basically means a bullet. I just named it gun for some reason.
If it collides with anything other than a bullet, and the only thing other than a bullet is the asteroid. So if it collides with an asteroid, then load scene 1, which means load the game over scene.
Game over scene, yeah.
Understood. Okay.
You can actually see that here. I can actually show that. If I go to my build settings, you can actually see that. So scene 1 is game over.
Yes, I see it. There's an index for the scene in 0 and 1. Perfect.
Yeah.
Okay, thank you. I think I'm on the same page. We can go further.
Okay, so this is the update function, and an update function in Unity is actually a pre-built function, which runs every single frame on your computer. So if your computer is able to run the game at like 60 frames per second, this function is going to run 60 times a second.
Wow. Okay, so this is the main function that allows us to define all our logic of motion, shooting bullets, and, well, could have been collision, but you're not doing collision manually. You're doing collision through Unity's game system, so you just do it through an event handler. on collision enter, right? That's why line 48.
And there's actually different types of updates. There's a fixed update, which means it's not like updates sometimes weird because like your computer's gonna switch around frames. But a fixed update is gonna be same frame rate
update is
every
better,
time.
Right? Better for performance.
And there's also update is usually better for this stuff. There's also late update, which is gonna run after each frame. So
why would you use late update?
Usually people use it for like camera
things you want to do
movements or
after the
something
main
like
game
that.
action has happened, right?
Yeah,
makes sense. Okay, things where a lag is okay.
Yeah,
right? Yeah, because you wouldn't want to lag in including logic. No, it makes sense. All right, so let's go ahead and, in the interest of time, let's just start. So, okay, fine. You're highlighting the start function. You're saying that this gets called once, and the update function in line 34 gets called at the whatever FPS your computer can go at.
Yeah.
Right. Okay.
Start just runs on the first frame of the entire game. Like it runs whenever the first frame is.
Okay.
There's actually also a wake. It's like usually used for like initializing everything, like setting your variables, that sort of stuff.
And in this case, you're initializing a variable called RB, which stands for rigid body. And you're simply initializing it to the component rigid body that you've created elsewhere. Yeah.
So if you use get component without anything before it, like if you didn't do game object, like if you didn't do like gun one pause dot game get component like that, it's just gonna get the component rigid body from the current game object, which is.
I think for anyone who has done 3D before with our courses at Camp K12 would understand that much like what you have in Hatch, this is an entity component system. So the entity in this case is unspecified and you're just getting a component. But if you specify an entity, you can actually search the component within it. And so every game object has a rigid body if you've enabled it, right? This is the physics engine. Yeah. So you're actually storing a reference to the physics body of this spaceship, right? That's what RB is?
Yes.
And we're going to be using it for I'm guessing our motion and all of that stuff now.
Yes, we're actually not going to be using it for our rotation. It's only going to be for forward and backward.
Forward and backward. Let's do it.
All right. So I would say first thing we should do rotation. That's just easier to do. So you can use, we're going to be using a lot of if statements. And if statements are basically you give it an argument, it returns true or false based on that argument. So if you say like if 0 equals 0, it's probably going to return true. So what we're going to do here is we're going to say input dot get key key code dot a. Or you could also put left arrow, but I like A because I like to use WASD. So what this does is it returns true every time you click that button. So if you click A, it's going to return true. So just to test that, we can put debug.log.
I love it. This is such a pro coding trick, which is to start printing stuff as you code so that you can see it actually.
A.
Yeah.
We can just put that there. Okay. So now if we go back to our game. Yeah, it's going to show up in our console. It's going to say click A.
Okay, so you're going to now press the arrow key A, and you're going to see if it actually does it.
Yes. Just, okay, it's loading in. It sometimes takes a little bit to load all the scripts in.
No worries, and this is what I was telling your audience.
Yeah,
so guys, Unity is awesome, but it is also, it's heavy. All right, there it is. I see it. You're printing clicked A, so that your code is working over there at the bottom. Okay, awesome.
See,
so Rohit, in the interest of time, I'm going to ask you to go ahead and code up the logic of motion and then explain it all together at once rather than as we go.
Okay. All right. So
you can explain it as you type, but let's just do it in one flow, and then we'll zoom out and look at what we've done.
Okay.
It's quite advanced.
I'm multiplying it times time dot delta time just so that it rotates the same amount for like every frame rate, not like
depends on the FPS of the system.
Yeah, I don't want like someone with a faster computer to be able to rotate faster than someone with a slower computer.
Wow. I mean, I'm just so impressed by the kinds of game development knowledge that you have. It's just crazy. I have not met a sixth grader that knows as much as you know about game development. This is very impressive.
This is the part where we actually use the rigid body. We do rb.addForce, which is a really very cool thing that Unity has.
Okay.
You can just add force, like push stuff. Literally, basically push stuff. We're basically going to do transform.forward because we want to be able to move forward. We're actually going to have some parentheses around it. We're going to multiply it times the speed. Yes. And then we're going to say multiply that times time.
Sure. Yes. So guys and gals who are watching, there is a lot of stuff going on here. And explaining each of these lines of code fully is going to require more time. But maybe I can try while he's coding to explain what's happening. Transform refers to the ship's transform controls.
I can show it.
Right. Yeah, perfect.
This loads in. Scripts loading in takes forever. Okay, there we go.
Yeah.
Spaceship. Yeah, there it is. Transform.
Good. So guys who've used Hatch, it's that section on the top right where it says X, Y, and Z of the position, the rotation, the scale. The position, the rotation, and the scale of the ship can be accessed via the transform object. And what I noticed is you also access transform.forward, which is a built-in, I think, property of the transform.
Yep.
Which, no matter what the rotation is, always refers to the direction, the vector, the direction in which the ship is pointing, right?
Yes.
So that is really cool. Yeah.
Yes. That makes it a lot easier for us because we just put transform.forward, it goes forward.
So Rohit, now that you've written some awesome code, let me just tell our audience what each of these lines does. Let's start with W and S. W and S are the front and back keys on the keyboard.
Yes.
W moves the ship forward and S moves the ship back. A rotates the ship to the left and D rotates the ship to the right. You could have done it with arrow keys, up, down, left, right, or you could have done it with WASD. He's done it with WASD. And what's important here is he's changing the transforms on the ship. So he's actually changing the rotation of the ship in line 39. He's changing the rotation of the ship in line 43 when you press the A and the D keys. Now, for the forward and back keys, he's not changing the rotation. He's simply saying whatever the current forward direction is, move in that direction. But rather than setting the position, so remember, transform has position, rotation, and scale. Rather than setting the position, he wants it to animate to that, not just suddenly go there. So he's not just setting the position to some magical number. He's using physics. And those of you who are in high school or probably later years in middle school will understand forces allow us to accelerate objects. And what he's doing is he's adding a force. I'm guessing the spaceship has a mass as well, right?
Yeah,
so
it has, its mass is 1.
Perfect. So, a force, what it does is it causes an object to accelerate at a certain acceleration depending on what its mass is. And so he's causing the ship to accelerate forward in line 47 and to accelerate backwards in line 51. And here's the catch. He uses transform.forward because he's accelerating in whatever direction the ship is pointing rather than in a fixed direction. And he's
transforming
back.
It's negative transform.forward here.
Yeah, perfect. Let's move on.
Okay. I also want to just talk about the different kinds of forces you can add, which is really cool. You can add 4 types of forces: force, impulse, velocity change, and acceleration. I mostly use force and impulse. The difference is force is more like a continuous force. It's like you're slowly pushing something to some destination. And impulse is more like you're throwing a ball. You don't keep pushing the ball anymore. It's just gone. That's it.
Okay.
So, yeah. Because we're moving, we want to be able to control that spaceship as long as we want. So we're going to put force. Okay.
Great.
So now we should be actually able to move and rotate, which is really cool.
So now we're moving on to step 2.
Yes, we can move now.
Hey, I just noticed you're cloning the asteroid in one of the other scripts. Is that in the spawner script?
Yes, that's in the spawner script.
If
Technically,
you guys look
this
at the left side.
Yeah, when I'm playing, you can actually see some asteroids spawning here.
I saw those entities appear over there, which I think is really cool. So our team built HatchXR. We did not add this feature, which lets you dynamically see an updated list of entities on the left side for things created in memory. But Unity allows you to see that. I think that's pretty cool. Go ahead.
And you can actually see them actually getting deleted as they go on.
Yes, I can see that. And I think it's really helpful for someone learning game development to show them that. Yeah. And wow, guys, I just noticed the ship is moving. It's moving so beautifully. Wow.
Oh no, right. I'm off the screen.
I think it's time to do bullets.
Yeah. Okay. So the bullets is where it gets kind of it gets interesting.
Let's spend 10 minutes, not more than that, on shooting and bullets, because I want to save at least 5 minutes to take questions from the audience. All right.
Okay.
All right. Great.
We're gonna just speed run this. Okay, so you could do shooting 2 ways. You can either make it so that they just keep shooting bullets while you hold the spacebar down, or you can make it so it shoots one time every time you click it. I'm just gonna make it so it keeps shooting. Spacebar, and so first you need to instantiate an object, which basically makes a clone of the object you give it. So we're gonna do game object bullet 1 equals instantiate. Oh god, no. Okay, instantiate, and then we have to give it, if you see here, object original. So the original object is
okay, and you declared that up there. Can you just show us that you declared it up in
the
variable section?
There it is. If you remember at the start, we assigned a bullet in the.
He's making a. So yes. Are you basically cloning it?
Yeah, I'm basically cloning it. So I think
for those of you who don't know the term instantiate, it's a technical term, it's a programming term, but he's basically cloning the one bullet game object and storing that new clone in a variable of type game object called bullet1.
Rotation doesn't really matter because it's a sphere. Like, it doesn't really matter, but...
Right. It would have if you were using like a cylinder to represent a bullet.
Yeah, it would, yeah. But since we're not, it doesn't really matter, but you have to give it a rotation. It doesn't really matter. Just give it. Okay, so now if you did play it, okay, I'll just show you what happens right now. It does spawn in bullets, but it doesn't actually shoot them. It just spawns them everywhere, does nothing, absolutely nothing. So if we play now, it spawns in a lot of bullets, but like doesn't do anything. Like it just doesn't go forward. It just pushes our ship around. That's not very helpful. So we need to actually shoot. So to make them shoot, it's going to be very similar to this, except we don't actually have a reference to these bullets' rigid body yet, so we have to get it. So we have to do bullet1. Okay, bullet1 dot get component rigid body parentheses and then dot add force. Just put after it. There we go. And it's basically going to be the same thing. Transform dot forward.
Same thing we did to move the ship forward. You're doing to move the bullet forward.
Yep. Shoot speed.
While you're doing this, I'm going to ask the audience if they have any questions. Okay. So audience members, if you have any questions, please ask right now. And we're going to look at your comments on the side. If there's something you don't understand, ask us. This is perhaps one of the most advanced sessions we've had on Camp K12 TV in a very long time. And Rohit is obviously a superstar 6th grade game developer. And I can imagine that not everything here is making sense because we're going really fast. So if you guys would like to ask Rohit any questions, please ask. And Niharika, if you see any questions being asked on the chat, please let us know. You can just tell us via the Zoom. All right.
Okay, so it actually does shoot now, which is very quick.
Does it? I didn't see it.
Yeah, it shoots. It actually shoots. There it is.
Oh, wow.
Yeah, it's like an insane speed. You can just mess around with the speeds.
It's moving
But
super fast.
you can see that it never deletes the bullets. It just
Yes. They just keep going.
yeah, it's gonna just fill up your RAM and eventually destroy your computer.
man.
So we need to fix that.
Yes, let's fix that.
So I did give you guys a function to delete bullets. So I already pre-coded a destroy bullet coroutine, which will destroy bullets after 8 seconds.
So, okay, 965 says this coroutine runs how often? How does it work?
It runs, it's like a function. It only runs once, but so coroutine allows you to like have wait for seconds, that sort of stuff. It allows you to have waits it allows you to it allows you to wait for something, but like without stopping the
So
time.
is it running every 8 seconds? Is that how I should interpret it?
No, it's like it waits after you call this, after 8 seconds. After 8 seconds after you call it, it's going to do this stuff.
So you have to call it. Got it.
Yes.
I understand. Okay. This is not like an event handler and it's not a timer. This is a function. We're going to have to call it. It's a coroutine.
Yeah, we have to do start coroutine.
Oh, okay.
Destroy bullet. And then in the parentheses, just put bullet 1 and bullet 2.
Yep. Because it takes 2 bullets as a parameter.
Yep. There we go. So that's basically you can now shoot. Technically, you can now shoot and it does delete the bullets. Yeah, after 8 seconds, it's going to destroy the bullets.
Oh, I get it.
So that means your RAM will not get destroyed.
Can you shoot?
Yeah, your RAM won't get destroyed.
All right.
Okay, you know what? I think the shoot speed should be lower. It's kind of insane.
And how did your bullets get deleted randomly? Did you stop playing?
Yeah, I did. After you stop playing, it deletes everything.
Yeah, it deletes all the objects that were dynamically created. Okay.
Yes.
All right.
Oh, that's better. There we go.
That is really good. And then can you just shoot? Okay, let all the bullets get destroyed. Don't shoot. I just want to see it. Are the bullets getting destroyed?
Yes, there we go. They're all destroyed.
Oh, nice. Can you just shoot one bullet? A single. There, stop. Guys,
okay, I know how to make it so the single bullet. I'll just literally one word down.
No, don't do it. Rohit, don't do it. I know you can. I was just trying to show the audience that after 8 seconds, each bullet is getting destroyed. Right?
Okay. All right.
That's all I was trying to show them. And
all right.
this makes sense. So I now understand what you've done. So the moment you fire a bullet, you create 2 new bullet things, which are spheres. You apply a force on them to make both of them go. And right when you create the bullet, when the space key was pressed, you launch a coroutine for those 2 bullets specifically, for the 2 clones that you have just now created. So each time you press space, you create 2 bullets and you call a function that passes those 2 bullets by reference and says 8 seconds after right now, delete these 2 bullets, right? Yeah. So if I hit spacebar once, those 2 bullets are stored in memory to be deleted after 8 seconds. Then you press the function again, and then again 8 seconds after. Yeah. Those 2 new clones are asked to be deleted. I think this is really brilliant, the way this is structured. In Hatch, those of you guys who code Hatch with Camp K12, you could use a different sort of syntax to achieve the same thing. You could use a timeout in Hatch to kind of sleep for some time and then delete bullets. All right, awesome. So actually we've done what we promised.
Yeah.
Right? So now can you show us how to turn this into a 3D thing? Last part, which is just how do we rotate the camera?
All right. Let me just open up Unity, the editor. Okay. So if you see here, if you scroll out a little bit, there's like a camera icon. If I zoom in on it, there's a camera icon. If you select it in the hierarchy, you can actually see what it sees.
Yes.
So you can actually just use the tools to move it.
And this part is like Hatch. This part is like Hatch, where you
can rotate it like this.
Nice.
And then you can move it down more. You can literally just position it where you want.
Oh wow! So it's already a 3D game.
Yeah, it's literally just
and rotate it a bit more.
Yeah, you gotta move it back and up a bit. Oh no, that's like a. Okay, I can't find a good position for it, but.
Don't worry.
That's pretty good. That's pretty good.
Yeah, that's pretty good. So now you're going to render the game. You're going to run it. And let's check it out.
Yes. There we go. It's 3D.
Oh, wow. Wow. Guys, round of applause for Rohit for what he has just achieved. I think you promised us 60 minutes and you did it much less than 60 minutes. This was phenomenal.
Yeah.
Niharika, do we have any audience questions for Rohit? All right. Wow.
Oh, that's actually there's actually a system for that in Unity too.
Let's do it. Let's do it. Whoever asks this question is a lucky kid. He's going to show you how to do it.
So if you right click on the hierarchy and go to effects, there's actually a particle system, a trail, a line, all of that particle system. And it has a default particle system. You can literally customize this with 3 billion settings.
In fact, in your other game with the rocket lander thing, moon lander, you had a particle system. You had that.
Yeah, I had a particle system for the thrusters. If you see here.
That's cool. Yeah. That's the particle.
Yeah.
Nice.
So you can literally customize this however you want.
Do you want to try to make a trail, like a flame for the rocket?
Okay, wait. I think I already have it.
It depends on how long it will take. If it's going to take a long time, we'll go to the next question because Niharika has 7. All right, let's go to the next one. Rohit, we'll go to the next one. I think you've shown the audience what they wanted to know. All right, go ahead, Niharika.
So as I said, I know how to do Python like a lot. It's another one of my favorite languages. I do some Scratch. I do a bunch of HTML, CSS, and JavaScript. I do a little bit of Java and a lot of Unity and C#.
And how old are you again?
I'm 12.
More power to you, man. I'm very excited for what you're going to give back to this world in your life. Yeah. And, I think everyone in this community must be feeling really inspired because we have 400,000 kids coding and learning different things. And we always feature some of our students on Camp K12 TV, and we will every week. But, this is a chance for young people across the globe to see what other young people are doing. And I'm sure you've inspired a lot of other people, not just in 6th grade, not just the 12-year-olds, but the 13-year-olds, 14-year-olds. I know you've inspired me. So this is really awesome. You've inspired me to keep doing what we do at Camp K12 and to keep bringing this skill set to young people like you. So thank you for that. Niharika, any other questions you'd like to share with Rohit?
You can only use C# to code in Unity. Well, they like a really long time ago, they used to have JavaScript and C#, but like it became really messy because it was like 2 languages, so they just removed JavaScript.
Interesting.
I mean, technically, if you build this game to WebGL, which is a platform, so if you build it to WebGL, what you can do, it gives you like a file, and if you take that file and put it into one of your websites, you can actually like put your game into your website. Yeah, you
can embed it. You can embed it. Those of you who use, go ahead, Niharika. I won't take any more time. Over to you for more questions. I think that's a great question. Yeah, just change the layout of your game really quickly.
Like,
add some 3D models, maybe change the background.
all right, I'll just change how the asteroids look, I guess.
Sure.
All right, so you can just create an empty object. I'm just going to create like a weird asteroid thing. It's just going to be tons of cubes put on each other. Technically, it's art, very beautiful art.
And guys who are watching this, it's very similar to Hatch. In fact, it's very similar. You have these primitive shapes like spheres, cubes, etc. He's creating his own asteroid out of a bunch of cubes right now. Wow. And then he's scaling the whole group. That's awesome. And if you guys look at the starry background is actually what's, what is it called? Is it a star field?
Skybox.
Skybox.
It's a skybox.
It's a skybox.
Yeah.
Okay. All right.
You just got to give this thing a rigid body. Wait. Rigid body. I mean, if it's your first time, I feel like it's hard. It's a little bit itty bit hard to understand it first time, but after that, it's like really fun. It's not very hard to figure out stuff after that.
And that's why we are here for you as well. That's why I'm here. That's why Niharika is here. That's why the whole community is here to give you the curriculum, the time and space, all of that. That's why we're here to support you guys on that journey. Rohit, go ahead.
Like once you learn the basics, it's like the best thing ever. Like changing the code? No, really. Whatever model you put for your spaceship, it's not gonna be different. It's literally gonna be the same.
You could have like a Superman flying like that and
shooting lasers.
Yeah, exactly. Guys, did you see what he did? By the way, while we were all asking questions, Rohit has changed his game to add a particle system for a flame trail, and he's added his own custom asteroids. So to your point about designing, I think while we were so busy listening to him answer questions, he did some magic. I didn't even notice. I'm noticing it now. That's awesome. That's very awesome.
Yeah.
Niharika, any other questions? Sure. So guys, I think we are at the end of our session, and that is a wrap for episode 39. Rohit, how do you feel? How was this?
It was really fun. I like teaching.
You are a phenomenal teacher, my friend. And the way you communicate so clearly, it's one thing to be a great coder. It's another thing to be a great articulator and a great teacher. Coincidentally, Camp K12 has just launched its Art of Communications course as well. And you teach public speaking now along with teaching coding. And I think you just exhibit both of those skills so nicely. And so thank you for sharing your time with us. We're waking up at 6 a.m. on a Sunday morning in Fremont, California, and joining us for this. For the audience, by the way, next weekend, I'll be back with you. Similar time, most likely on Sunday, but stay tuned, we'll announce it. Similar time for a young kid, 1 year younger than Rohit, 5th grader, teaching how to code your own cryptocurrencies. All right. So we'll have another bright young super coder from the Camp K12 community teaching you guys how to build your own cryptocurrencies like Ethereum and Bitcoin 1 week from today, most likely. Stay tuned for the details on that. If you guys like to code, if you guys like to build things, the next few sessions are going to be really awesome on Camp K12 TV, and I'm going to try to join as many of them as I can. So Rohit, thank you so much once again. And everybody, take care. Have a great rest of the weekend for those of you who are in the western part of the world, and have a good week ahead for those of you in South Asia and Southeast Asia, and have a great time. Bye, guys.
Thank you for giving me this opportunity to teach.
Thank you, Rohit. Thank you. Bye-bye.